Let's dive into automatic speech recognition, or ASR for short. It is the magic that turns spoken words into written text. It is like granting our machines the gift of listening and comprehension. Think about its uses: transcribing meetings, powering voice assistants, aiding the hearing impaired. Truly, ASR is reshaping our interaction with technology. Now let's see ASR in action. We have got an audio file here. Once we send this to our ASR, it will listen and then scribble down what it hears. Let's see how accurately our system has transcribed our given audio snippet. So here is this file. Let's listen to it.
And so, my fellow Americans, ask not what your country can do for you, ask what you can do for your country.
So, as you can see, that's what it did. And so, my fellow Americans, ask not what your country can do for you, ask what you can do for your country. First things first, we are importing the pipeline function from our library. It sets everything up for our task, which in this case is speech recognition. Once our library is ready, we move on to set up our transcriber. We are picking the automatic speech recognition model provided by Zenova, and we are particularly choosing the Whisper Tiny English model for this. Time to get our hands dirty. We are giving our transcriber an audio URL. It will take a moment to listen and process the audio. And there we have it. Our transcriber listened to the audio and gave us back the exact words spoken. If you have an audio file on your computer and it is not online, you can still use it. First, we turn the audio file into a special link using url.createObject URL of the file. This gives us a special link that our program can read. After we get this link, we pass it to our transcriber. Want to know when exactly each part of audio was spoken? We can. By adding the return_timestamps:true parameter, our transcriber not only gives us the transcript, but also timestamps for various chunks. As we see here, the speech began with, and so my fellow Americans, right at the start, and around the 7.74 second mark, it transitioned to ask what you can do for your country. We can also get timestamps for each word, showing when it was said. We will see that in the implementation. To handle audios that are longer than 30 seconds, we use a special approach. We divide the audio into smaller parts and transcribe each one. Here we are breaking our audio into 30-second parts using chunk_length_s. But to ensure we don't miss words at the edges of these parts, we overlap them by 5 seconds using stride_length_s. So the last 5 seconds of one part is the beginning of the next one. Now we come to the implementation. Let's go to the audio category and select automatic speech recognition in English. So I'll click on that and we will open this page. Here we are passing the audio URL. Here we are using a local file, and then we generate timestamps per chunk and per word, and finally we translate or transcribe longer than 30 seconds. So let's go back to the Visual Studio Code. Here we have this page for ASR English. So as usually at the top, we start by creating the script tags. We created of type module because we want to use the import statement inside it. Here we are importing the pipeline function from the Transformers.js library. Of course, if you want to access that, you can go to the Transformers.js website, go to installation, and below here you will find this URL. Then our next step will be to attach the pipeline function on the window object. This is because objects declared inside a script of type module are local, and to make them global, you must attach them to the window object. Okay, let's go down to the initialize model method, this one. So what we are going to do now is that we are creating the transcriber by invoking the pipeline. We pass automatic speech recognition as task, and then we specify the model that we will use. Now, to see this model, we can go back to the Transformers.js, go to the pipeline API, and below in the audio, here in the audio automatic speech recognition, we have the models, and these are the available models. Let's look what model we have here. Whisper Tiny English. So yes, this is Whisper Tiny English that we are using. Let's go back to Visual Studio Code. Now with the transcriber ready, let's go below and handle the first button, which is transcribe English. So I will now get the URL from the input, from the text input, and store it in a variable. Then we will call the transcriber, passing to it the URL. The transcriber will take long time, so that's why we make this await, and that's why we make this async, because if I am going to use await, the method must be async. Now when that is ready, it will return the text and store it in the result. Let me close this. Now what we will do in the last line, we will convert the result to a string, and we will output that in the output area. Let's now go and test that. So here is the URL that we specified. I will transcribe now. It takes some time, but as you can see here, we are getting the text. Of course, we listen to the audio, and that's what the audio says. Okay, so the next part is that if we don't have a URL, if we have a local function, a local file, sorry, so that's what we do here. We will get the file input object. From this file input object, we will get the first selected file. We only have one selected file. Then we will check if the file doesn't exist. We will alert and return. Then we will create an object URL of that file using the URL.createObjectURL and passing the file. That returns a URL for us. We can call the transcriber with this URL as before, and then here we convert the result to a string and output it in the output area. Let's also test that. So I'll choose this file. We have these files in the project. So I'll do transcribe. Okay, so now you see that this has been transcribed. Now just let me show you the files. If you go to the audio folder, you have the 3 files that we are using in this tutorial. Okay, so the next step, we will, with the transcription, generate timestamps for the main chunks of the audio. So to do that, we do everything as normal. We get the URL from the text input and store it locally. Then we call the transcriber, passing this URL and passing a JavaScript object with a key return _ timestamp :true. We set it to true. That means that it will return timestamps for the main chunks. It will return the result, and we will convert to string and output it. Let's test that. So this is the one. So as you can see, here is the return, the transcribed text, but also the first chunk, which is this, As you can see, it has a timestamp from the beginning up to 7.74. And at 7.74 up to 10 seconds, we had the second chunk. Okay, so what if we want timestamp for each word spoken? It is exactly the same. The only difference is the value of the return timestamps will not be true. It will be the string word. Everything else will be the same. Let's test that. Okay, the transcribed text is as usual, and here you can see the place or the timestamp for each word, and so my up to the end. For the last part, which is an audio which is longer than 30 seconds, in this case we have to pass some parameters because we will need to transcribe it each 30-second alone. So what we do here is we get the URL as normal, we call the transcriber as normal, and then we pass two keys. The first key, chunk underscore length underscore s, we set it to 30, saying that divide the audio file to pieces of 30 seconds. Now then I put stride underscore length underscore s. This is the overlap between the chunks. So the last 5 seconds of the first chunk are the first 5 seconds of the second chunk, and so on. We do that to avoid getting some parts of the word ignored. So after we do that, we just get the result and we output it to the output area. Let's do that, but before doing that, let me open the file, the audio for you. So this is the audio. It is 1 minute. I will leave it with you.
So in college, I was a government major, which means I had to write a lot of papers. Now, when a normal student writes a paper, they might spread their work out a little like this. So, you get started maybe a little slowly. You get enough done in the first week that with some heavier days later on, everything gets done and things stay civil. And I would want to do that like that. That would be the plan. I would have it all ready to go, but then actually the paper would come along, and then I would kind of do this. And that would happen every single paper. But then came my 90-page senior thesis, a paper you're supposed to spend a year on. I knew for a paper like that, my normal workflow was not an option. It was way too big a project. So I planned things out, and I decided it kind of had to go something like this. This is how the year would go. So I'd start off light, and I'd bump it up.
Okay, so this is the audio that we are going to transcribe. Let's go to the web application and transcribe. So this is around 1 minute, so it will take longer than what we saw above. It will be divided into 30-second chunks, and it will be transcribed using them. Okay, so as you can see, it managed to transcribe the whole script.